Good afternoon, students. Today is the day number 3 of Basic Calculus Vocabulary class. Let's go. We have 5 new words in Calculus Vocabulary class for this day. Strictly increasing decreasing function, polynomials and polynomial function, power function, root function, and rational function. This is the corresponding Chinese translation. In the right side is important because the quiz has some question regarding to this. Next one. Strictly increasing and decreasing function. In calculus, a strictly increasing function and a strictly decreasing function are terms used to describe the behavior of a function with respect to change in its input. On the one hand, a strictly increasing function is a function f(x) is considered strictly increasing on interval if, for any two values of x within that intervals, let's call them x1 and x2, the following condition holds: x1 is less than x2 equal to fx1 less than fx2. In other words, in simple words, as the input value increase, the corresponding function values also increase. There are no flat portion or interval where the function remains constant. On the other hand, a strictly decreasing function is a function f(x) is considered strictly decreasing on an interval if for any two values of x within the interval x1 and x2 the following condition holds: x1 is less than x2 equal to fx1 greater than fx2. In this case, as the input value increases, the corresponding function value decreases. Next one. Example sentence. It's important to know that the term strictly increasing and strictly decreasing imply a stronger condition than just increasing or decreasing. A strictly increasing function never has two distinct input values in the same interval that map to the same function value, and similarly for a strictly decreasing function. Next one. The next word is polynomial and polynomial function. In calculus, a polynomial is a type of mathematical expression involving variables and coefficients where the variables are raised to non-negative integer power and multiplied by the corresponding coefficients. A polynomial can be true of as a sum of terms, each consisting of coefficient and variable raised to a non-negative integer exponent. A polynomial function is a function that can be represented by a polynomial expression. More formally, a polynomial is defined as follows. A polynomial in one variable x is an expression of the form of the following form. Next one. Example sentence. The example sentence, the term polynomial function refers to the function that is defined by a polynomial expression. There are some examples: equation 1, 2, and 3. Example of polynomial function: px, qx, and rx. We can observe the different grades, degree. For example, the first one, a polynomial of degree 4, because the greater exponent is 4. The second one, a polynomial of degree 3, because the maximum exponent, according to this equation, is this polynomial is x3. And the last one is the degree is 2, because the maximum exponent is 2. Next one. Power function. In calculus, a power function is a specific type of function that can be represented by an expression of the form fx equal to ax exponent n. Here, fx is the function, x is the variable, and a is a constant coefficient. N is a real number, which is the exponent. The power function is named as such because it involves raising the variable x to a constant power n. Next one. Example sentence. The power function can take various forms based on the values of a and n, but the power function plays a significant role in calculus, particularly when analyzing the derivative and integrals. The derivative of a power function can be found using the power rule. For example, the derivative fx a n x exponent n minus 1. This rule provides a straightforward way to calculus to the derivative of a power function based on its exponent. Next one, root function. In calculus, a root function refers to a function that calculates the nth root of a given value. Mathematically, the nth root of a number a is denoted as the square n a, or a exponent 1 between n. The root function is used to find a number that, when raised to the power of n, result in the given value a. For example, the square root is a common root function where n is equal to 2. Next one. Example sentence. The square root function graph starts from the origin and gradually approaches the x-axis. When x is negative, the square root function is underdefined in the real number system. We can appreciate the graph of a square function like a parabola. Y is equal to x exponent 2. Next one. Rational function. This is the last word for today. In calculus, a rational function is a function that can be expressed as the quotient of two polynomials, where the numerator and denominator are both polynomial functions. Mathematically, a rational function is of the form fx is equal to function px between function qx. Here, px and qx are polynomial, and qx is not a zero polynomial to avoid division by zero. The example sentence, the rational function fx equal to the polynomial 3x exponent 2 minus 2x plus 5 divided into x minus 4 represent the mathematical relationship between a quadratic polynomial in the numerator and a linear polynomial in the denominator. We can observe in the graph the limit is an important concept in calculus. We can observe the first limit fx equal to infinity, and the other limits limit fx is equal to a. Thank you so much. After that, we are going to take the quiz in Kahoot. Good luck.